Yes, students. In this question, we are learning about the conversion of velocity into distance. In the previous sessions, we have learned displacement into velocity, velocity into acceleration. That conversions we have learned. There we use the differentiation. In this, we are learning about the conversion of velocity into displacement. That in this case, we have to use the integration. Look at the question. The velocity time relation of an acceleration, the velocity time relation of an electron starting from rest is given by V is equal to kT, where k is 2 meters per second squared and V is in meters per second. The distance traveled in first 5 seconds they are asked. In this question, initially the particle electron, who is a particle here? Electron. Electron started from rest. Initial velocity is equal to 0. Okay, now velocity is changing with respect to the time. Velocity is equal to kT. K value is what, sir? 2 they given. They are asking the distance traveled in first 5 seconds. That means from the time, where to where the time is changing from 0 to 5 seconds. Velocity, initial velocity is nothing but initially it is a u. That is, for example, they given as a starting from rest, they said initial velocity 0. Final velocity we have to calculate. Initial velocity 0 they given. Final velocity we have to calculate. Then how can we find out that final velocity? When that final velocity, after 5 seconds, the velocity they are asking. They given the condition is also velocity is the time variable. That means velocity they given as a kt. You know that velocity is nothing but rate of change of displacement. V is equal to dx by dt. V is equal to what? Dx by dt. Okay. Now velocity is equal to dx by dt they given. When you compare these, can I write dx by dt is equal to kt? Now this equation I'm writing like as a dx is equal to kt dt. What is the meaning of this equation now? When the time changes dt seconds, then the displacement is dx. A small duration, if the time changes, dt seconds, the time changes, then the displacement is how much here? Dx. But here time is changing from where to where? 0 to 5 seconds. When the time changes from 0 to 5 seconds, what is the final velocity they are asking? What is the final velocity they are asking? To find out that one, final displacement they are asking. Final displacement they are asking. So to find out that one, all the displacements has to be calculated. Okay, now all the displacements has to be added. Okay, now to add, instead of adding here, what we are doing? Integration we are doing. So if you do that integration, integral of dx is equal to integral of kt dt. The meaning is what, sir? Addition of all the displacements and meanings. Okay, now integral of dx is nothing but there is a formula. Integral dx is equal to x. You might have studied in a integration concept in mathematics. Integral of dx is equal to x. Here initially I'm taking the limit as a x1. Final limit I'm taking as a x2. So integral dx is x from x1 to x2. Here k is the constant. Take it outside. Integral t. T power is how much here? 1 is there. Integral of x power n is equal to integral of x power n dx is equal to x power n plus 1 by n plus 1. There is a formula in an integration. Integral of x power n dx is equal to x power n plus 1 by x n plus 1. In this question, integral t power 1 is there. In the place of x, we have the t. In the place of n, we have the 1. So integral of t power 1 dt is there. So from x1 to x2, k into integral t power 1 is nothing but t power 1 plus 1 by 1 plus 1. That is 2 by 2. From where to where? Time limits they given already. 0. First 5 seconds they said. First 5 seconds 0, 1, 2, 3, 4, 5. That means 0 to 5. So 0 to 5 seconds. Substitute that x2 minus x1. What we have to do here? First of all, you substitute the upper limit in the place of x, that is x2, minus substitute that lower limit in the place of x minus x1 equal to k. K value they given here. What is the k value? They given as a 2 meters per second square. So I'm substituting the k value 2 and substitute that upper limit in the place of t, that is 5 square by 2 minus lower limit 0 square by 2. x2 minus x1, final position minus initial position. That is nothing but total displacement. S is equal to 2 into 5 square by 2, 25 by 2. 0 square by 2 is nothing but 0. I'm eliminating, I'm not taking that one. 2 gets cancelled. Therefore, displacement is equal to, what is that? 25 meters. So, first option is the correct.